Good day, everyone. My name is Chadwell Yasran, and I am the sixth reporter of our group, which is Group 2, and our topic is all about polarization. So, we have here the first topic that was assigned to me, which is charging a two-sphere system using a positively charged object. Now, as what we can see, the graphic below in which a positively charged balloon is brought near sphere A. On the other hand, the presence of the positive charge induces a mass migration of electrons from sphere B towards and into sphere A. So now I want you to focus on the diagrams. And it is okay if you cannot see clearly the words below since I will be explaining it to you. So now let's focus on the diagram 1. So, naman unsa atong makita ari, di ba makakita ta sa two metal spheres wherein wala pay negative charge or positive charge. And it makes them neutral. Then, on the second diagram, as what we can see, naanay positively charged balloon. So, naaman kita yung simple principle wherein it states that opposites attract and then like or what we call the same kay mo repel. So since kay positively charged man siya, so automatically all the negatively charged electrons of the sphere A and sphere B will be attracted to the positively charged balloon. So this movement of electrons from sphere B to sphere A leaves sphere B with an overall positive charge and sphere A with an overall negative charge. So now let's go to the third diagram. So as what we can see there, the sphere B is separated from sphere A using the insulating stand wherein the two spheres have opposite charges. Now with the positively charged balloon still held nearby sphere A, it makes the sphere B physically separated from sphere A, and the excess positive charge is uniformly distributed across the surface of sphere B as what we can see on the third diagram. And on the other hand, the excess negative charge on sphere A remains crowded towards the left side of the sphere, positioning itself close to the balloon. So now let's move forward to the fourth diagram. So makita nato ari sa fourth diagram nga gi-remove na ang positively charged balloon. So what will happen if wala na kato ang positively charged nga balloon? So it makes the electrons redistribute themselves about sphere A until the excess negative charge is evenly distributed across the surface. And in addition, in the end, sphere A becomes charged negatively and sphere B becomes charged positively. Now we have here induction charging process with a pair of pop cans. So as what we can see in the diagram, we have two pop cans that are mounted on styrofoam cups using scotch tape. And again, it is just okay if you cannot see clearly the words below since I will be explaining to you. Just focus on the diagram itself, okay? So, as what we can see here on the diagram, the cans are placed side by side and a negatively charged rubber balloon wherein kani siya nga negatively charged rubber balloon kay girab siya sa animal farm nya it is brought near to one of the cans. And on the other hand, the presence of the negative charge near a can induces electron movement from can A to can B nga makita nato ari sa atong diagram. And on the other hand also, once the cans are separated, the cans are charged. Then now, kay na-separate naman nato ang two cans, it is the time to test or to see whether ang type of charge nga naa sa can will attract or repel to the negatively charged balloon. So of course, we would expect or thought that a can A with the positively charged would attract the negatively charged balloon, and can B being negatively charged should repel the negatively charged balloon. However, during the process of induction charging, the rule of the balloon is simply induce a movement of electrons from one can to the other can. And also, it is used to polarize the two-can system, wherein the balloon never does supply electrons to can A unless guys, you hear a spark indicating a lightning discharge from the balloon to the can. So now we have here the electroporous. So what is electroporous? So it is a commonly used lab activity that demonstrates the induction charging method. So now in this lab, we have a flat plate of foam which is rubbed with an animal fur in order to impart a negative charge to the foam. And now guys, I want you to look at the first diagram. So in there, electrons are transferred from the animal fur to the more electron-loving foam. Then in the second diagram, we consider that an aluminum pie plate is taped to a styrofoam cup, and then the aluminum is a conductor and the styrofoam serves as an insulating handle. And also, as the aluminum plate is brought near, electrons within the aluminum are repelled by the negatively charged foam plate, wherein there is a mass migration of electrons to the rim of the aluminum pie plate. And take note, at this point, the aluminum pie plate is being polarized. Yes, it is being polarized with the negative charge located along the upper rim farthest from the foam plate. And now, let's move forward to the third diagram. So as what we can see there, the rim of the plate is then touched, which provides a pathway from the aluminum plate to the ground. And also, electrons along the rim are not only repelled by the negative foam plate, but also, take note, they are also repelled by each other. So once touched, there is a mass migration of electrons from the rim to the person touching the rim. So you can see there on the third diagram. So now we have here the fourth diagram. So as what we can see there, being of much greater size than aluminum pie plate, the person provides more space for the mutually repulsive electrons. And also, the moment that electrons depart from the aluminum plate, the aluminum can be considered a charged object. Yes, it will be considered as a charged object. And on the other hand, having loose electrons, the aluminum possesses more protons than electrons and is therefore positively charged. And now we have here the last diagram or the fifth diagram. So makita na to diha nga gi-remove na ang foam plate. So what will happen if gi-remove na ang foam plate? So the excess positive charge becomes distributed about the surface of the aluminum plate in order to minimize the overall repulsive forces between them. In addition, we have here an important details or information. So, the electroporous law further illustrates that whenever we charge a neutral object by induction, the charge being imparted to the object is opposite that of the object used to induce the charge. And also, in this case, the foam plate was negatively charged and the aluminum plate became positively charged. On the other hand, the law also illustrates that there is never a transfer of electrons between the foam plate and the aluminum plate. The aluminum plate becomes charged by a transfer of electrons to the ground. And finally, one might note that the rule of the charged object in induction charging is to simply polarize the object being charged. Moreover, this polarization occurs as the negative foam plate repels electrons from the near side, inducing them to move to the opposite side of the aluminum plate. And also take note that the presence of the positive charge on the bottom of the aluminum plate is the result of the departure of electrons from that location. And lastly, we should always remember this one, that protons did not move downwards through the aluminum because the protons were always there from the beginning. It's just that they have lost their electron partners. Yes, they lose their electron partners. And also, protons are fixed in place and incapable of moving in any electrostatic experiment. And that would be all for my assigned topics. And thank you so much for listening. Goodbye and God bless us all.